Hello dear students, this is Amanpreet Kaur taking session of class 10th, video 3 of chapter circles. In this video, we are going to start with theorem 10.2. I hope you have seen the previous two videos and you have completed your first exercise of chapter 10. In this video, we are going to do the second theorem, and there are only two theorems in this chapter. First theorem was radius is perpendicular to the tangent at the point of contact. If you see this diagram, figure 10.7, you will see this is the radius, right? And this is the tangent, right? Now first I should explain you what do you mean by this. This P is the external point and Q is the point of contact, right? So this angle is 90 degree. Angle PQO is equals to 90 degree because radius is perpendicular to the tangent. The tangent can be extended, right? So this is our first theorem and we had done the proof of this theorem. Now second theorem. Before starting with the second theorem, here the word is written length of tangents. What do you mean by length of tangents? Let us say this is a circle whose center is at O, right? This is the center. And now there is an external point P, and from this P I can draw the tangents, right? From the external point I can draw two tangents, right? This is intersecting the circle at point Q and this is intersecting the circle at point R. Therefore Q and R are the point of contacts, right? Now what do you mean by length of tangent? Length of tangent is the length from the point P to the point Q, right? Length of the tangent is the length from the external point P to the point of contact. So this PR is also the length of tangent, right? And now in this theorem we have to prove that the length of tangents drawn from an external point, this point external point, right? And the length of tangents, there are written S. So PQ and PR are the length of tangents. They are equal. We have to prove these. They are equal. That is what we have to prove. PQ is equals to PR. This is what we have to prove. And whenever you find it, there are two tangents from an external point, then the length of these two tangents will be equal. How these are going to be equal? Now let us see the proof. In this, we will join OQ and OR as it is done in this figure 10.7, right? Now we know that this is 90 degree and this angle is also 90 degree. Angle ORP is 90 degree, right? Now we will join PO also, right? So we got two triangles. Which two triangles? In triangle OQP and triangle ORP. I hope it is clear now. First triangle is, let me draw it with the different pens so that you can easily understand this. This is first triangle OQP, right? This is first triangle. Now let us draw the another triangle with another pen. This is triangle POR, right? POR. So which two points are coming common? PO, right? So you will write, how will you write the proof? In triangle PQO and triangle PRO. PO is equals to PO, right? One is common. This is written here, right? Second thing, this angle is 90, angle Q is 90, angle R is 90, right? So you can write angle Q is equals to angle R by each 90 because radius is perpendicular to tangent, right? Third condition, what you can say here? OQ is equals to OR. Yes or no? Yes. Why? Because these are the radius and the radius are always equal. So OQ is equals to OR, right? Radii. right? So now what three things you have got? What three things you have got? First is you have got this. If this is 90 degree, it becomes the hypotenuse, right? And this is 90 degree and this is other side. So you got one 90 degree, you got one hypotenuse, and you got other as the other side. So three things: right angle, hypotenuse, and one of the side. So by RHS, these two triangles are congruent, right? So these two triangles are congruent. So here you can see these two triangles are congruent by RHS, right? So then by what is by condition by CPCT? Yes, PQ is equals to PR. So this gives PQ is equals to PR by CPCT. Hence proved. So this theorem is very important, and mind it, you are going to use this theorem in 90% of the questions of chapter circles. The length of tangents drawn from an external point to a circle are equal, right? So this is the proof of this theorem. I hope it is clear to everyone now. Now moving on with the exercise 10.2, examples will be taken on, but first we will start with the exercise 10.2. In this exercise 10.2, first question is, from a point Q, there is a point Q, the length of tangent to the circle is 24. What is given to you? Length of tangent. So it means that point Q is the external point. This is the circle. Let us take this point Q. The length of tangent to a circle. Since it is given length of tangent, so we will draw only one tangent, right? This is the tangent, right? This is the length of tangent. Let us give its name as R, right? So this is equals to 24 centimeter, right? And the distance of Q from the center, this is the center, O is the center, length of Q from the center, it means this is given to us, that is 25 centimeter, right? Find the radius of the circle. Radius is this. This is what we have to find, and we know that this is 90 degree because radius is perpendicular to tangent, right? So let us see its proof. Only Pythagoras theorem we will apply here. Let us see its proof now. Let us see its proof. See its proof now. Here I have explained you the diagram, right? How to draw the diagram. This is the point Q. The length of tangent is 24 centimeters. So this PQ is 24 centimeter. The distance of it from the center is 25. So OQ is 25. And we know that radius is perpendicular to tangent. So it means first theorem we are doing here, using here. So you have to write. So starting, how you will do starting, as radius is perpendicular to the tangent at the point of contact, therefore OP is perpendicular to PQ, right? Or we can say angle OPQ is equals to 90 degree, right? So this is how we will start it, because whatever we have to write it, we have to attempt it. We will not get marks without writing this theorem statement. So now applying Pythagoras theorem. So Pythagoras theorem you will apply, that is perpendicular square plus base square is equals to hypotenuse square. What is perpendicular square? OP square. What is base square? That is 24 square is equals to what is hypotenuse? 25 square. So you have to find OP, and OP will come out to be 7 centimeter. Therefore radius of the circle is 7 centimeter. I hope it is clear to you now, right? So moving with the second question now. In the second question, if you will see the second question is in figure 10.11. This is given to you. This is figure 10.11, right? TP and this is TP and this is TQ are two tangents, right? These are the two tangents to a circle with center O such that angle POQ is 110 degree. POQ, this angle is given to you 110 degree. What is angle PTQ? What is angle PTQ? It means this angle you have to find out, right? So again, by looking at this figure, what can you conclude? This angle is 90 degree, right? Angle P is 90 degree, angle Q is 90 degree. So out of these four, you got three angles: P angle, O angle and Q angle. Three angles you got. It becomes a quadrilateral, isn't it? PTQO becomes a quadrilateral. If you see this, PTQO, this becomes a quadrilateral, and three of the angles you know already. So you know that by angle sum property of quadrilateral, angle P plus angle O plus angle Q plus angle T is equals to 360 degree. Angle sum property of quadrilateral, you have to find it, others you know. Yes, so it's become simple now. Let us see its proof now. If you see the proof of this question, it is very easy. See its proof. Now, it is given that TP and TQ are tangents, right? So radius is perpendicular to the tangent. Radius is perpendicular to tangent, right? So this is your angle OPT is 90 degree, angle OQT is 90 degree, right? So now in quadrilateral POQT, sorry, sum of all interior angle is 360 degree, because this is angle sum property of quadrilateral. So add all the angles, it is equals to 360, you will get angle PTQ is equals to 70 degree. This is your answer of question number 2. I hope it is clear to everyone now, right? So moving with the third question now. In the third question is, if tangents PA and PB from the point P, since PA and PB are the tangents, from which point? P point. Therefore, P is exterior point of the circle. Mind it, P is the exterior point of the circle. Yes, right? To a circle with the center O are inclined at an angle of 80 degree. So what this figure implies, that there is point P, PA and PB are the two tangents. They are inclined at an angle of 80 degree. So it means angle between these two tangents is 80 degree. I hope it is cleared now. So you have to find angle POA. Where is O? This is center O. You have to find angle POA. This angle you have to find, right? So how will you solve this question? So let's see its proof now. In this you will see this point P is external point. So first what you will do, let me draw the diagram again. It will be easy for you to understand. This is external point P, this is A and this is B. These are the points of contact. There is O point, right? So we know that this is 90 degree and this is 90 degree, as we have done second questions, right? Radius is perpendicular to tangent and this angle is given to us as 80 degree. So we have three angles again, right? Let us change its pen now again so that it will be easily understand now. So these three angles, you know, angle P, angle A and angle B, right? So again PAOB is a quadrilateral. So can you find angle O? Yes, you will find this angle and this angle will come out to be 100 degree. It is exactly same as question number 2. Till it you have done now, right? So what next you will do? You will join a line PO, right? So PO you have joined. Now you got two triangles. This is first triangle and this is second triangle, right? So in these two triangles, what you will take? Again, as you have done that 10.2 theorem in triangle OPB and OPA, right? In these two triangles, OPB and OPA. This is OPB and OPA. These two triangles, what you will write? Angle A is equals to angle B, each 90 degree because radius is perpendicular to tangent, right? Second is, yes, OA is equals to OB because each radii of the circle, and what is common? OP is common. So these two triangles are congruent, right? So next what you will do, you can write here RHS, or simply you can solve it by SSS also, because you know that length of tangents are also equal, right? Let me again explain you this concept. See, if you can't take angle 1 and angle 2, so first side is OP is equals to OP, common. OB is equals to OA. Why? Radii of the circle. PA is equals to PB. As theorem 10.2, length of tangent from an external point to a circle are equal, right? So by SSS criteria, triangles are congruent. By CPCT, what you will get by CPCT? Yes, by CPCT you will get two angles are equal. Which two angles? This is first and this is second. Let me name it angle 1 and angle 2, right? So you will write angle POA is equals to angle POB, right? I can write here POB is equals to POA. These two are equal, right? But what is full angle? Full angle is 100 degree, right? So it means these two angles are equal, it means they are equally divided, right? So each angle you will get as 50 degree, right? Each angle you will get as 50 degree. So what is this angle now? This angle is 50 degree. This is the proof. So which option is correct? A option is correct. Is it clear, everyone? Yes. So it seems once you practice it, once you solve it in your copies, you will find these chap questions easy, right? So you knew now how to solve it. Moving on with question number 4. In this question number 4, prove that the tangents drawn at the ends of the diameter of a circle are equal. What is given to you? Tangents. It is drawn at the ends of diameter. So if I draw a diameter, I knew diameter passes through the center of the circle and AB is the diameter. Now I have to draw the tangents at the ends of diameter. It means I have to draw the tangents from A as well as from B. These are the tangents, and I have to prove that these tangents are parallel. It means I have to prove that these two lines are parallel. So is it, this question is clear to you, everyone? Yes. Now let us see its proof. So how will you see its proof now? So this is the diagram. So it is clear now. I have already explained you the diagram of this. Now how will you prove these two lines are parallel? Parallel means, what can you think of parallel? Either alternate interior angles are equal or corresponding angles are equal, right? These two are the meanings of parallel lines. What do you mean by alternate interior angles? This is angle 1 and this is angle 2. I have to prove angle 1 is equals to angle 2, and it seems the question is cracked. We knew it. Yes, apply your mind. Yes. Now what is OA? OA is radius, and what is this now? Tangent, and we know that radius is perpendicular to tangent. So angle OAR is 90 degree. Now moving on with this OBQ. This is again 90 degree. Again radius is perpendicular to tangent. From these two, what I got? Angle 1 is equals to angle 2. And what they are making? Alternate interior angles. How the alternate interior angles are made? When the two lines are there and there is a transversal, this line is transversal cutting the two lines. So whenever we got Z and alternate interior angles are equal, then the lines are parallel. Hence these two lines are parallel, right? So this is how you are going to write. Let us see its written portion. Now let AB is the diameter of the circle, P, Q and RS are the tangents respectively at point A and B. Now OA is perpendicular to RS. OA is perpendicular to RS, it means OA is perpendicular to RA also. Now OB is perpendicular to PQ, radius is perpendicular to tangent. So this is perpendicular 90 degree. So alternate interior angles are equal. If the alternate interior angles are equal, then the lines are parallel. Right? So this is the proof of this question number 4. Moving with the question number 5 now. In question number 5, what you can see? Question number 5 is prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. In this question, what is given to you? There is a perpendicular at the point of contact. Let us take this tangent. This is point of contact P. The perpendicular, this is perpendicular, it means this angle is 90 degree. So you have to prove this passes through the center of the circle. Obviously we have shown that radius is perpendicular to tangent, and if we extend this line then it will pass through O. But we have to show its proof. How we will show its proof? Let us see. What we will do is, we have to prove that the line perpendicular to AB passes through O, right? We will prove it by contradiction method. What do you mean by contradiction method? Contradiction method is the opposition of what we have to prove. We will take the opposite of that. So what we will assume now, we have done this method when we have done irrational numbers. We have to prove that root 2 is irrational number, this type. So what we have taken at that time, let root 3 is a rational number. So after that, at the last, we come to know that it is not a rational number, it is irrational number. Similarly, this question also we will prove like this. Now see, let us assume that the perpendicular AB does not pass through the center O. It passes through center O dash, right? And in this diagram, O dash is given to you, right? What is our assumption? That PO dash is perpendicular to PB, right? PO dash is perpendicular to PB. This is our assumption. So it becomes 90 degree. Also we know that radius is perpendicular to tangent. We have done this theorem, and theorem can't be neglected. So angle OPB is also 90 degree. This angle OPB, right? So if both the angles are 90 degree, then implies both the angles are equal. How can it be possible कि other point O dash is there and O is also there, but both the angles are equal with respect to PB, with respect to the same tangent? So it can only be possible if this O dash coincide with O. I hope it is clear. Coincides with O. O dash coincides with O. It means O dash is over O, right? So let me again explain you. This is O, this is P, and here is again one more line. Let me draw it with another pen so that it will be clear to you. Another line PO dash, such that they are overlapping. So it means they are coinciding. O and O dash are coinciding. So it means this O and O dash is coinciding. Hence, what we have to prove? The line perpendicular to AB passes through the center, right? This is our question. So I hope this is clear to you, everyone. And now till here you have to do the questions, and the rest questions will be taken up in the next video. Till then, practice, practice and practice. Practice how to write the statement, practice how to understand the statement.